Hi everyone, welcome to today's session. This is Akshay, Faculty of Mathematics, Vivek Vidya Youth Forum, New Delhi. So in this session, we will be taking about exercise 1.1 of the chapter Real Numbers. In previous session, we have learned a few example numericals which are based on Euclid's algorithm of solving HCF using Euclid's algorithm. This is the session 3 based on the chapter Real Numbers. So let's see. Use Euclid's division algorithm to find HCF of 135 and 225. 135 and 225. So I have just taken a copy which I had prepared for other classes. So I have just displayed it over here. So let me just take the pen. 135 and 125. Since 225. Since 225 is greater than 135, apply Euclid's division lemma by taking A as 225 and B as 135. Find Q and R using the formula A is equal to BQ plus R such that you get this as the equation. Right. So upon simplifying, you get Q as 1 and remainder as 90. So 90 is not equal to 0. So again, apply Euclid's division algorithm to find B is equal to 135 and R is equal to 90. So later on, by taking 135 is greater than 90, you will apply Euclid's division algorithm. You will get the quotient as 1 and remainder is 45. So 45 is not equal to 0. Again, apply Euclid's division algorithm. You will get quotient as 2 and remainder as 0. So since the remainder is equal to 0, the divisor in this case, in this stage, will be the HCF of both of them. What is the divisor? 45 is the divisor. 45 is the divisor. So it is the HCF of both 135 and 225. Clear? I'll clear the screen so that you can copy it down. Children, copy it down. Done copying. Let's go ahead to the next question. First question is done. Second question is HCF of 196 and 38220. This is such a simple question. You will get to know why I say it as simple enough. So as it is, we will take 38220 is greater than 196. Apply Euclid's division lemma, taking A as 38220 and B as 196. Later on, 196, 195 times is 38220. Quotient is 195. Remainder is equal to 0. In the first step only we are done. Remainder we are getting as 0. So divisor in this stage is the HCF of 196 and 38220. So what is the divisor we have taken? We have taken divisor as 196. So 196 is the HCF of 38220 and 196. Note, there is one note over here. HCF of A comma B. If A is the factor of B, and here 196, because 196 is a factor of 38220. So HCF is 196. So it should be exactly a factor of that number. So then only we can consider it as the HCF. Copy it down. Let's go ahead further. This question is done. Next question here will be 865, 867 and 225. 867 and 225. Let's see the solution. Eight 67 is greater than 225. Euclid's division algorithm. You get quotient as 3 and remainder is 102. 102 is not equal to 0. Again, apply Euclid's division algorithm. You get quotient as 2 and remainder is 51. 51 is not equal to 0. So again, apply Euclid's division algorithm. You will get quotient as 2 and remainder is 0. So divisor here is 51 in this case. I'm sorry. So 51 is the HCF of 867 and 251. Sorry, 255. 867 and 255. I'll clear it off. If I'm going a bit speeder, if I'm going a bit fast, decrease the playback speed while watching the video. Okay, so that you can make it. Okay, as you all know, there will be a concept behind after solving each kind of question. So why we give this concept insight? Why we give this concept insight? This is because any other number which is given in the exam, you should be able to solve it. You should not feel any difficulty in solving that. 9 out of 10 cases, it will be the questions which we solve in the class. The same questions will come. But if in case a different question come, you should not feel difficulty, right? So only we give this concept insight. So concept here is to crack such problems. Remember that to apply Euclid's division lemma, which states that given positive integer a and b, there exists a unique integer q and r satisfying a is equal to bq plus r, where 0 less than or r lies between 0 and b. So A is greater than B. Euclid's algorithm works since dividing A by B, replacing B by R, and A by B, repeating the process of division algorithm till the remainder is 0. Right. So which divides A and B exactly. So this R divides A and B both exactly. So therefore, note, do not find HCF using prime factorization in this question when the method is specified, and do not skip the steps. All the steps are taken into consideration while solving these kinds of questions. Okay. Make a note of it, concept insight. I say it's very important to know the concepts. Let's move ahead further. First veil question is done. Second veil, show that the positive odd integer is of the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is sub-integer. Let an odd positive integer, we need to prove that a is of the form of 6q plus 1, 6q plus 3, 6q plus 5, where q is sub-integer. Since a is an integer, consider b to be 6 as another integer so that Euclid's division lemma can be applied. So later on, you get it to the standard form and say q is greater than 0 and r lies between 0 to less than b, right? So 0 to 5 it is, right? Therefore, this statement, then when r is 0, a will be 6q. When r is 1, a will be 6q plus 1. When r is 2, a will be 6q plus 2. When r is 3, a will be 6q plus 3, and so on, 6q plus 5. So we know that a is odd, so it cannot be 6q, 6q plus 2, and 6q plus 4. Since they are all divisible by 2. They are all divisible by 2. So it is 6q plus 1 is 3q plus 1. 3q is nothing but k1, which is a positive integer. 6q plus 2 plus 3 means 3q plus 1, which is again a positive integer, k2. 3q plus 2 for 6q plus 4, which is again a positive integer, k3. So 2k plus 1, k is an integer. Therefore, 6q plus 1, 6q plus 3, 6q plus 5 is an odd number. So therefore, it's an odd number which is expressed in this form where q is a positive integer. This statement is compulsory and this is important. Okay, they look for the statement just because it's a conclusion that you have proved it. You have proved it correctly. Copy it down. Let's move ahead further to the concept. In order to solve such problem, Euclid's division lemma is applied to two integers a and b. Is an integer must be taken in accordance with what is to be proved. For an example, your integer b is taken 6, but we must get the form of 6q plus 1, 6q plus 3, and 6q plus 5. Basic definition of even and odd numbers, and the fact that addition and multiplication of integers is always an integer is applicable here. We are taking this fact into consideration. Copy it down. Very important. Very important. Do not forget to write all the concepts so that your different numbers, different types of questions, once you understand the concept inside, you will be able to apply it. Next question. We are done with the second one. Third one, an army contingent of 616 members is marching behind an army band of 32 members in a parade. The two groups are to march the same number of columns. What is the maximum number of columns in which they can march? I've already told you how to read the word problems. First, you will read it very slowly. Second time, you will read it as story. Third time, you will make a note of it. One take. Here, I underline the word maximum. I will say why it is maximum when we come to concept inside. I will say why it is maximum. Underline the word maximum in the question. So here only they have given maximum number of columns in which army contingent band gives us, we have to find HCF of this. Euclid's division algorithm. Find the HCF. You will get quotient as 32 and sorry. You will get quotient as just a minute, you will get quotient as 19 and remainder as 8. 8 here is not equal to 0. So again apply Euclid's division algorithm. You will get quotient as 4 and remainder as 0. So the divisor in this case, that is 8, is the HCF of 616 and 32. Do not forget, you have to write what they have asked, number of columns, right? So you have to conclude by saying 8 columns each. 8 columns each. This statement is actually accepted. If this statement is missing, you will be taken off 1 box. 1 box will be taken away mercilessly. Copy it down. Let's go ahead with the concept. In order to solve the word problem, first step is to interpret the problem and identify what is to be determined. The keyword maximum means we need to find the HCF. Do not forget to write unit in the answer. That is what I told. Do not forget to write 8 columns in the answer. Do not forget to write the unit in the answer. Right? Third question is done. Fourth one here. Use Euclid's division lemma to show that square of a positive integer is either of the form of 3m or 3m plus 1 for some integer m. Okay, understand this problem properly. Fifth one you will be solving. I will just display the answer. You will be solving it. Fifth one. It is similar kind, but just cube they have given. You can solve it. And I say this int should not be used. Don't read this int at all. Okay, you assume, you separately understand the question and write, because in the examination int won't be given. There won't be any sort of int given for any question in the examination. Let a be a positive integer. We need to prove a is of the form of 3m or 3m plus 1 for some integer m. So let b be 3 and odd integers. So apply Euclid's division lemma to a and b is equal to 3. Upon applying Euclid's division lemma, r can take the value 0, 1 and 2. So the square of them they have told. So find over here, you get this, where k1, k2 and k3 are respectively the q, the portion of q part. This is k1, k2 and k3. Since q231 etc are an integer of is of sum or product. We have told in the previous question, addition and multiplication of an integer is an integer itself. Addition and multiplication of an integer is an integer itself. So you can see over here integer. So k1, k2 and k3 is an integer. So henceforth it is said that square of a positive integer is either of the form of 3m or 3m plus 1 for an integer m. For an integer m, 3m or 3m plus 1 is the integer, positive integer. Copy it down, children. Next question, you will be solving it by your own. That doesn't mean that I don't know how to solve that question. I know how to solve that question, but it becomes a practice for you also. It's easy question. You can solve it. So before going to the next question, let's see the concept. In order to solve such problems, Euclid's division lemma is applied to two integers a and b. Integer b must be taken in accordance to prove. This is same. For an example, b is taken as 3. We must be of the form of 3m or 3m plus 1. Do not forget they have taken it as a square, to take it as a square. Note the variable is just a notation. It's not an absolute value. Okay. K1, K2, K3 we have taken. No, it's just a notation. Copy it down. Let's move ahead further. We're done with the fourth one. Fifth one, Euclid's division lemma to show that cube of n positive integer is of the form of 9m, 9m plus 1, 9m plus 8. Try it out, dear children. Try it out. In another few minutes, I will display the solution. You can keep on trying it by pausing the video. Let's see the solution. This is what is the solution. Copy it down for those who were unable to solve it. 9 out of 10 cases, you should be able to solve this, because previous question also it's the same, but there it's square, here it's cube. That's it. Nothing else difference. Let's move ahead further. See the concept. In the problem, Euclid's division lemma can be applied as integer a and b equals 9, as well as by using 9 will give us 9 values. of R, and hence has many cases, so solution will be lengthy. Since every number will be divisible by 9 is also divisible by 3, so 3 is used. So it's a clue over here. In order to simply put 9 and go, the solution becomes even more lengthy. So rather put it as 3, you can cut down few steps. And do not forget to take a cube and different values of a, you will get it as this. In this case, this is only for this case. This is for all the cases where you might get it as cube of a number. So right over here, we have solved these many questions which were given in exercise 1.1. Hope all of you have understood. If you have really understood this video, please click on the thumbs up button, share this video, and would expect to clarify your doubts in the comment window. Do comment it. Thank you. Stay home, stay safe. Let's meet in the next session.